Let us take a look at this question next. If a matrix has 24 elements, what are the possible orders it can have? And what if it has 13 elements? Now, there are two questions involved in this. If a matrix has 24 elements, what are the possible orders it can have? Let's take a look at this. For forming a matrix, we have to have number of rows, some number of rows and some number of columns, and the total number of elements. For example, for a matrix of m by n order, the total number of elements is equal to mn. That's the total number of elements. For example, let's say there are 3 rows and 2 columns, so number of elements would be actually equal to 6, as you can clearly observe, right? There can be another case, let's say if I have another order, maybe 2 by 3. Now what happens in that case? Number of elements would be equal to what? Number of elements is again 6 only, right? Multiply 20 through it. Let's take another example. What happens in case I have 6 rows, I have a matrix having 6 rows and 1 column. 6 rows and 1 column, yes, 6 rows and 1 column, something of this sort. This is a matrix having 6 rows and 1 column. How many elements do you think are there in this? This also has 6 elements. Similarly, I can have a matrix having order 1 by 6, that is 1 row and 6 columns. What do you mean by that? 1 row and 6 columns, yes. I can have this element. This is a matrix having 1 row and 6 columns, as you can observe, right? And the order is 1 by 6, and yes, number of elements would be 6. Now what is special about these orders? When we consider this particular number of elements, what is special about these orders is, as you can clearly observe, these are nothing but the factorization of this particular number 6. We are writing 6 as product of 2 numbers, right? We are writing 6 as product of 2 natural numbers for that matter. That's what you can observe. And once this particular concept is clear to us, then we realize that if a matrix has 24 elements, let's try to write 24 as product of 2 factors which are natural numbers, right? And those will be the possible orders of the matrix, right? So 24 can be written as, let's try to begin with the smallest one. 24 can be written as 1 by 24. The smallest number of rows can be 1, right? The next factor that I can think of is, as you may observe, 24 gets divided by 2, and what you get is 2 by 12 is another possible order, right? Okay. We could also have 3 by 8. 24 gets divided by 3, right? 24 has a factor 3. 24 has another factor 4 as well, right? This is 4 by 6 as well. What else? After that, 5? No, 5 is not a factor of 24. 6 is a factor of 24. And what happens with 6? 6 times 4 is what you get. So 6 times 4 is already, 4 times 6 was already present. 6 times 4 is nothing but reverse of this. We could also have 6 times 4, 6 by 4, right? This is one possible order, and this is another possible order. What happens in case of 6? After 6 we need 7. No, 7 is not a factor of this. The next factor would be 8 only, and the possible order that you would get is 8 by 3. After that, obviously, the next would be 12 by 2. Do I need to check 9, 10, 11? No, you don't need to check 9, 10, 11. The order will be this only. This is 24 by 1. Next. Right? So this is how you find the possible orders of a matrix having 24 elements. There are 4 plus 4, 8 possibilities. 8 possibilities in total, right? Those are the number of possibilities. Next, what are the possible orders? These are the possible orders. What if it has 13 elements? What if the matrix has 13 elements? What are the possible orders the matrix may have? So let's try to factorize 13 as well. Now when we realize that factorizing 13 does not give me much options, this can be 1 by 13 or it can be 13 by 1. Does 13 have any other factors? No, 13 does not have any other factors. Only factors are 1 and 13. So this is one of the possible order, and this is another possible order for this matrix having 13 elements in total, as you can see over here, right? Is that all? Yes. Let me get a slide. You can take a look at this. This is all in this question over here.